So state the formula for NPR. That is simply n factorial over n minus r factorial. That was just, that's all you need to do there. Order matters, right? You don't have to have this part, but when we're using permutations, order matters, right? State the formula for NCR. It is n factorial over r factorial n minus r factorial. Okay, order doesn't matter. Irrelevant. So try to think it through, right? What is this scenario focusing on? Are we making teams? Are we making groups? Or are we kind of, is it important to keep things in a certain order? Will it make a totally different arrangement if we switch things around? Okay? Another example is if you want to make a juice, right? You want to make a juice and you have 10 fruits available to you. Okay, how many ways can you make a juice with 3 ingredients, like selecting 3 ingredients? Does it matter which order you put the fruit in the blender? No, right? You're going to just blend it all up. So, right, like that scenario kind of tells us, oh, we're just choosing 3 at a time. Okay, doesn't matter which order. It wouldn't make the juice taste different. We just put it all in the blender and there you go. Okay, so keep that in mind. State the number of ways to rearrange Ardvark. So that is 7 letters. So we know our n is 7, so that would be 7 factorial for sure. And let's see here my notes. 2 A's, and we've got 2 R's. It's a little blurry, right? There you go. So we need to divide this by 2 factorial like that. That gives you 1260. Okay, so show me the setup and then just give me the answer. Okay. What if the first letter is a V or a K? I see why some of you chose to do the work in the back. It's probably a good idea. It's a little crowded here. But what do you think of or? I think of cases, add. So I would go like this and like this. So one case that I consider is where there's a V, and then I consider the case where there's a K. So you start with a 1, and what is left over? I still have 6 letters that I need to arrange. And since the V doesn't affect the repeats, right? The repeats are still mingling there, so I still need to divide that out. Same here. A K is not one of the repeats, so it's 6 factorial, 2 factorial, 2 factorial. So you do this, you do the bottom. So this is what, 720 divided by 4? 720 divided by 4, right? And then times 2. So what is that? 720. That's 180 and 180, right? And then if you add that up, that should be 360. So if you just manage to, do the work on the side here, just make sure that that's 360. There's 360 ways to do that. How many ways can you rearrange that if it must start with an A? And notice A is one of the repeats. So that's going to change how I do things. So the first letter is an A. Wait a minute, which A are you talking about? Both A's, Mr. Erickson? Technically, we're considering both of those because there's 2 A's in there. But we're not going to count both of those cases. So I get rid of any extras. I'm just going to consider the 1 case. So that's 1. And remember, you are left with 6 factorial. Okay, you remove 1 A at a time, right? 6 are left. And so you used to have 2 A's, now you just have 1 factorial, 1 A is left, and the 2 R's are still in the mix, so it's 2 factorial like that. The 1 factorial is not really needed, but this is 720 divided by 2, which is 360. Okay, so you get 360 there as well. Yeah, 360. How many paths are possible going 5 blocks east and 2 blocks south? I don't know if you were able to do this one. The idea is, so 1, 2, 3, right? 1, 2, 3, 4, 5 that way, and then 2 blocks south. This is the scenario you're in. You're going from A to B. Okay. So what would this be using the formula? This is 5 and 2, that's 7 factorial. Divided by, we're going 5 sideways, and we're traveling 2 south. And that gives you 21. I'm not going to do the counting method because it's too crowded. I can't make that work. Okay. All right. Let's keep going here. So we'll just do 1 mark each today. Okay. How many arrangements are possible for ranking the top 3 students? You're ranking top 3. There's no specific positions, right? It's just the top 3 combinations. Right. So from the 30, so this is 30 total. So we'll go 30, choose 3. And that is 4,060 to just get top 3. Yeah. Today it's 0. I know, it's harsh, I know. But it's okay. It's not going to affect you. This is not going to affect you at the end of the semester, not that much. 4 scholarships awarded if only 1 per student. So here you have 4 scholarships, right? Scholarship 1, 2, 3, and 4. So, yeah. Because you just want the top 3. We don't care about necessarily, we're not looking at who's first, second, and third. We just want the top 3. You know what I mean? So I don't really care who's first, who's second, who's third. I just care, I want to know like how many ways can I have 3 at the top? I know. But that's why it's combinations. If it's at first, second, third, that's different. Because like now you're like actually interested, like how many ways can I do first, second, and third? So it matters where you stand. Got it? Okay, that's where practice, the more you see, the more you're gonna be like, okay, wait a minute, this is not, they're trying to trick us here, right? So 30, 29, 28, 27, because only 1 per student. So we can only go give all 30 qualify for the first one. 1 of them gets it. Now you have 29, 28, 27. Or you go 30, pick 4. It's up to you how you answered that. Sorry, what am I doing here? Am I on the right page? 4 scholarships. Yeah. These are my 4 events. Right? So the first one can be awarded to 30, 29, 28, 27. So this is, I need to calculate this, 30, alpha window 7, that's 60, 657, 720. How many ways can 4 scholarship be awarded if there is no limit, meaning every student, like a student can actually win all 4? So this would be 30, 30, 30, and 30. So that's 30 to the power of 4. That's 810,000 ways that can be done. How many different groups of 5 students can be picked? Groups of 5, so we go 30, choose 5. 30, choose 5. That is 142, 506 ways. Okay? How many groups of 2 boys and 3 girls can be picked? So very specific, right? So that means that from the 12, I'm going to choose 2, and from the 18, I'm going to choose 3. Okay, that's what's happening there. They could have actually just told us 2 boys, right? We should have understood that, okay, that's exactly 2. I need a group of 5. So the remaining 3 I'm going to grab from the 18 that are left, right? So 12 choose 2 is 8, this is 816. And 12 choose 2 is 66. If you multiply it, it's 53,856. This one I'll give you, we'll just leave it at 1 mark. We'll just leave it at 1. I'll just make it easier today. There are 5 guys. As stated, how many ways can they be rearranged? And I do agree that there's not a lot of context, right? We're thinking if it's arranged, that is honestly most definitely permutation. If you're arranging, if you're sitting side by side, if you're lining up for a picture, that is permutation for sure. So one less thing to worry about. So that'll be just 5 factorial, which is 120 ways. How many ways can they be rearranged? The first person starts with a J. So you technically have cases here. There's Jim, John, and Jack. You've got three people that start with a J. So technically, if you want to, you can go like this. Okay, you've got Jim, John, and Jack. So there's 1, 1, 1. And so the first case that we're considering, if we take Jim out, there's 4 factorial ways to do the rest. Same here, 4 factorial ways to do the rest. 4 factorial ways to do the rest. So this is 24, 24, 24. You add that up, you get 72 ways to do that. How many ways can they be arranged if the J's are to be grouped together? I don't like this wording. So if this threw you off, I'm going to exempt you today if you get this wrong. It means like standing next to each other. Okay? And because it says arranged, it still tells you that we're standing in a row and that order matters. But now we're keeping them, the J's are together. They're beside each other. So we've got 1, 2, 3, 4, 5. Those 3 are sticking together, and then it's definitely 3 factorial, and then it's 1, 2, 3, right? We consider this one block, 3 factorial like this. So that's 6 times 6, that's 36 ways to rearrange them. How many ways can they be arranged if they're not to be together? We're going to go 5 factorial minus 3 factorial, 3 factorial, because this is them being together. So that's 120 minus 36. That's 84 ways to do that. JJJ. Okay, so total is 15. Total is 15. Question? Yeah. So just put your name and last name at the top, and